Solving equations by graphing and square roots. Okay, first of all, we're going to start off with a graph of a quadratic. When graphed, a quadratic makes a parabola. The solutions to a parabola are on the x-intercepts. So for this parabola, we would have solutions at x equals -1 and x equals 3. Be careful when you're asked a question like this to read the directions. The directions may have asked you to write them as points, so it would have been -1, 0 and 3, 0. Okay, we can either have 0, 1, or 2 solutions to a quadratic. This first graph is a graph of 0 solutions because it never crosses the x-axis. Next graph has 1 solution because it only touches the x-axis once. And the third one has 2 solutions. Okay, we're going to start off by graphing a quadratic and seeing where the solutions lie. So on this first one, if you recall from Unit 2a, we need to find our vertex by using -b over 2a. So -2 would be a +2 over 2 times 1. So for our vertex, we have the point 1, blank. In order to find the y-coordinate of our vertex, we just need to plug 1 into our original equation. So we'll have 1 minus 2 minus 3, which gives us -4. So our vertex is at 1, -4. 1, 2, 3, 4. Okay, so now we need to find some more points on here. I'm going to make my table here, put my vertex in the middle. So let's find a point to the left and to the right of this vertex. If I plug 0 into my function, I will get out -3. And since parabolas are symmetric, I know that if I plug 2 in, I'll also get out -3. So 2, -3, and 0, -3. Okay, so I'll need to find another one, so we'll go one more to the left and one more to the right. If I plug -1 into my function, I need to be very careful and use parentheses. So I have -1 squared minus 2 times -1 minus 3. So that would be 1 plus 2 minus 3. So here I will get 0, 1, 0. Again, since parabolas are symmetric, I know that I will get a 0 whenever I plug in 3 as well. So there's my graph, and as I can see, my solutions are at x equals -1 and 3. Okay, for this next one, we need to do the same thing, but first, we need to get everything on the same side of the equal sign, so I'm going to subtract over the 4x. Okay, we always have to have it in standard form first. So -b over 2a comes next. -4 would make a +4 on top over 2 times -2. So we'll get a -1. So for our vertex, we have -1, comma. Now if we plug -1 back in, again be careful with the negative and make sure it's in parentheses. So -1 squared is 1, times -2 is -2. -4 times -1 is a +4, and then a -2, which will give us 0. So we have the point -1, 0. Now if we look at our original equation, we have a -a value, so I know that my parabola is going to open down. And for the sake of just solving this quadratic, I don't need to find more points because I can see that there will only be one solution at x equals 1, and I can stop there. Okay, next we're going to solve by taking square roots. So notice first of all that in this first problem, we only have an x squared. We don't have an x anywhere. Same thing with this second problem, we have something squared. We don't have any just x's that aren't in a squared situation. So with this first one, we're going to get the x squared alone. Start by adding the 31 over. And then dividing by 4. Okay, so now that the squared item is alone, so now that x squared is alone, we're going to do the inverse operation of squaring, which is square rooting. So if I square root an x squared, I'm going to come out with just the x. The square root and the squared cancel each other out, and I just get what's on the inside. Now if I square root the left side, I need to square root the right side, and we need to simplify this square root of 20. Now, if you recall from Algebra 1, we just need to find the biggest perfect square that divides 20. So here are a few perfect squares written out for you. And the biggest one of those that's going to divide 20 is 4. So this is going to be just the square root of 4 times the square root of 5. The square root of 4 is 2, and we will leave 5 in the square root. So our answer is going to be 2 square root 5. Now, we need to have 2 answers for every problem that we solve. So the way we do that is we just put plus minus. We'll have both the positive and the negative 2 square root 5 as an answer. This is kind of like a lazy person's way of writing x equals 2 square root 5 and negative 2 square root 5. Alright, for the next one, we need to get this squared part alone as well, so we're going to divide both sides by 2. Now that we have the squared part alone, we're going to square root it to get it unsquared. And we're just left with x plus 3 from the inside. And the square root of 16 here is 4, but again, we need to put plus and minus 4 so that we get 2 answers. Now the way we continue to solve this is we write it once with the positive 4 and once with the negative 4. Subtract the 3 over, we get 1 and negative 7. Now, to check yourselves on these, we can always plug back that 1 and negative 7 into the function and see if we get a true statement. I'll show you how to plug in 1. So if we plug 1 in, we're going to get 1 plus 3, which is 4. And 4 squared is 16. So we would have 2 times 16, which does equal 32. So, oops, I said 32, but I put 33. So that checks out in our, at least x equals 1 is correct. You could also check x equals negative 7. Okay, go ahead and pause the video, work these 3 out on your own, and then restart the video to see my solutions. Okay, so as you see, I have the 3 problems done. Couple things to note is on the middle one, the 7 over 2 didn't simplify, and that's fine. You can just leave it as the square root of 7 over 2. This other one, the one on the right, notice I put the plus square root of 3 in the back. You may have had that in the front, but it's okay if it's in the back. Normally that's the best way to write it with the whole number in the front.